All right, so here's a couple of examples, or well, one example, but dealing with a couple of products of matrices, and it's the same product, well, it's the same two matrices, but multiplied differently. So here, in the first one, we've got the permutation matrix on the left. Here we've got on the right. We're going to see what the difference is. Now remember, if we look at this, what is this telling us? Well, this one here, okay, which one is that one copying? Well, if we do the first row, it's copying what? 7. 8 and 9. Now, since it's on the left, we're dealing with copying rows, right? So this one copies the third row, and where is it going to put it? It's going to put it in the first row of the product. So this here is going to take the third row, it's in the third column here, so it's in 1, 3, right? So it's going to copy the third row here and put it in the first row of the product. So this is going to be 7, 8, and 9. This one is in the first row, or excuse me, first column, second row. So this is going to take what? It's going to take the first row and copy it in the second row of the product. And you can see that by just, again, doing the multiplication. So second row times first column, it's going to copy that second digit. And where is it going? It's going in the second row. So this is going to be left the same. So this will be 4, 5, 6. And this one is going to take what? It's taking, or excuse me, hold on. Oh, first row. Sorry, copying the first row. Yeah, it's copying the first row and put it in the second column, or second row here. So this will be 1, 2, 3. And then of course, this one means that the 4, 5, 6 is going on the bottom because it's a permutation, right? We've got exactly 1, 1 in each row and column, okay? So we're moving things around. In this case, since it's on the left, we're moving rows around. Now what about this one? Now here, now we're flipping this multiplication, but now we're moving columns around. So again, if we look at this one, this is taking what? Well, think about it. Again, if you don't remember, look at it. So if we do the first row times the third column here, we get 1, 0, 0. So where is this going? So it's 1, 3. So it's in the first row, third column. Okay? And then if we do the second row, we got 4, 0, 0. So what is that? That's second column, third row. That's 2, 3. So 1, 3, 2, 3, 3, 3. That's the last column. So it's taking this column, right? So it's taking this column, the first column, and copying it into the third column. So that means this is going to be 1, 4, 7. Now this is the first one. So this was taking the first column and copying it in the third column here. This is taking what? The second column and copying it into the first column. So this will be 2, 5, 8. And then of course, the last column is going in the middle. So it's going to be 3, 6, 9. So we're moving columns around. All right. Now, if you haven't noticed, you should start seeing a connection between what we've been doing here and what we get when we perform Gauss's method and the Gauss-Jordan reduction. We've already seen how to produce a matrix that rescales rows and a row swapper. Okay? So now we're introducing how we can get all of this with these matrix operations. Okay, we'll do another example.